Good morning, everybody. Today, I would like to discuss flue gas analysis by Orsat method. This topic is useful for BSc Analytical Chemistry students and also BSc Chemistry students of 6th semester of paper Analysis of Applied Industrial Products. The outline of this lecture contains introduction, Orsat's apparatus, construction, working, and precautions. First of all, let us see what this flue gas is. Actually, flue gas is the combustion exhaust gas produced at power plants, boilers, fireplaces, ovens, furnaces, or steam generators. These gases are treated as pollutants. Actually, flue gas is the byproduct of combustion, normally released out through long pipes called as chimneys, otherwise called as flues. Large amounts of flue gases are generated around the world on large scales on a daily basis. Heavy industry and in particular power industry is responsible for large percentages of emissions. These gases are also released by wood fires and vehicle exhausts. First of all, let us see what this combustion is. Combustion or burning is a chemical process. It is an exothermic reaction. It's a reaction between the fuel and oxidizing gas like oxygen to release thermal energy. Energy may also be released in the form of light, noise, and electrical energy. In a complete combustion reaction, each element of the fuel compound reacts with oxygen to produce oxides of a particular element. For example, if we take the fuel, the natural gas methane, and when it is subjected to combustion, it releases carbon dioxide and water along with heat. Here in this reaction, here you can see the reaction. Here the carbon of methane gets oxidized to carbon dioxide and hydrogen get oxidized to water with the release of heat. Let us see the types of fuels. First of all, we should know what a fuel is. Most of the fuels are mixtures of chemical compounds called hydrocarbons. Hydrocarbons are nothing but a combination of hydrogen and carbon. Types of fuels. All the fuels are mainly categorized as solid, liquid, and gaseous fuels. Solid fuels include coal, peat, lignite, wood, and coke. Liquid fuels include light, medium, and heavy fuel oil, gasoline, and kerosene obtained after the processing of petroleum at petroleum refineries. Gaseous fuels include natural gas, LPG gas used for cooking purposes, coke oven gas, and blast furnace gas. Let us see what is complete combustion. It can also be called as theoretical combustion or stoichiometric combustion. In complete combustion, the fuel will burn in oxygen, producing a limited number of products. When a hydrocarbon burns in oxygen, the reaction will only yield carbon dioxide and water. Here you can see in the equation the fuel on oxidation, on combustion, it releases water and carbon dioxide along with heat. As pure oxygen is rarely available, so air is mainly used for combustion. As air contains oxygen and nitrogen, complete burning of a fuel involves release of carbon dioxide, water, and nitrogen. But complete combustion is impossible to achieve unless until the controlled conditions are maintained. Let us see what is partial combustion. Due to lack of perfect mixing between fuel and air in the combustion zone, and due to lack of spontaneous flow of fuel gas, excess air is required to achieve more complete combustion of fuel. Without extra air, formation of partial products of combustion such as carbon monoxide and soot may result, which will lead to environmental pollution. This is called incomplete combustion. Fuel gets wasted. So supply of too much air will decrease combustion efficiency. So a balance between too much air and not enough air is to be maintained. Need of flue gas analysis. The main need involves to reduce pollution, for saving energy and safety of mankind and safety of the earth. At present, one of the greatest challenges is to ensure air quality for power stations and industries. Cleaning of flue gas is very much important at these places. Otherwise, it becomes a threat to the environment. Let us see the components of flue gas. Flue gas is a mixture of different components. It contains carbon dioxide, oxygen, carbon monoxide, nitrogen, oxides of nitrogen and sulfur, hydrocarbons, hydrogen sulfide, hydrogen halides, water vapor, dust, soot, etc. Let us see what is an Orsat method. What is its use in flue gas analysis? In 1875, Orsat constructed an apparatus for the complete analysis of various gas mixtures, which is still used with slight modifications. Orsat gas analyzer is used to determine combustibles in the flue gases. Mainly percentages of carbon dioxide, oxygen and carbon monoxide by volume in flue gas can be determined by making use of this Orsat method. Orsat analysis involves finding of composition of combustion products in dry conditions. So there is no need to determine moisture content while flue gas analysis is being carried out. Here let us see the Orsat apparatus. Here it is, we see that in the diagram we can see it is an assemblage of so many parts. Here you can see the water reservoir, and here it is a gas burette, and these two are connected with a long rubber tubing, and here you can see a series of 3 bulbs which are called as absorption bulbs, and they are provided with stopcocks, and these 3 bulbs are kept in series, and they are attached to a long horizontal tube, and here you can see a 3-way stopcock which is fitted to the horizontal tube, and here you can see the U-shaped tube which has an inlet for flue gas, and it has an outlet. This outlet is connected to the long horizontal tube. Let me explain the construction of Orsat apparatus. It consists of a graduated gas burette which has markings on the surface to measure the volume of gas. It is surrounded by water jacket to maintain the constant temperature when the experiment is going on. The lower end of the gas burette is fitted with a long rubber tubing which is connected to a water reservoir. This water reservoir can be moved up and down. Here we have to remember one main point, that when we move water reservoir up, water enters into the gas burette and pushes the flue gas into the absorption bulbs. But when we move this water reservoir downwards, the flue gas rushes into the gas burette. Second one, gas burette is connected to a long horizontal tube which is fitted with a three-way stopcock. Here you can see a series of three bulbs A, B, C. Containing suitable absorbing solutions to absorb the different gases selectively. In the A bulb, potassium hydroxide solution is taken, which will absorb carbon dioxide. The B bulb contains alkaline pyrogalol or alkaline pyrogallic acid, which absorbs oxygen and carbon dioxide. In C bulb, ammonical cuprous chloride solution is taken, which absorbs carbon monoxide, oxygen and carbon dioxide. Hence, it is necessary that the flue gas is passed first through the potassium hydroxide bulb, where carbon dioxide is absorbed, then through alkaline pyrogalol bulb, that is B bulb, where only oxygen is absorbed because carbon dioxide has already been removed, and finally through ammonical cuprous chloride bulb, where only carbon monoxide will be absorbed. The U tube is fitted with an inlet and an outlet. Through the inlet, we can take the flue gas into the U tube, where the moisture is absorbed. If at all soot or dust particles are there in flue gas, it can be eliminated by putting glass wool in the U tube. It contains fused calcium chloride, it absorbs moisture because calcium chloride, anhydrous calcium chloride, which is hygroscopic in nature, and it absorbs moisture. The dry flue gas, after removal of moisture from U tube, the dry flue gas is now allowed to flow into the horizontal tube by opening the three-way stopcock. Then the gas is allowed to pass into the gas burette. Usually a definite volume of gas mixture, say 100 ml of gas, is taken for analysis. This is about the construction of Orsat apparatus. Let us see the working of Orsat apparatus. Flue gas analysis involves mainly three steps. First step is estimation of carbon dioxide, and the second step involves the estimation of oxygen, and the third step involves the estimation of carbon monoxide. Here it is an Orsat apparatus which is used in laboratory, and here the working. If we come to the working of Orsat apparatus, first of all we have to open the stopcock of potassium hydroxide. So first of all we have to open the stopcock of potassium hydroxide bulb, that is A bulb. Then water reservoir is moved up so that water enters into the gas burette, which pushes the flue gas into the KOH bulb. Here carbon dioxide in flue gas is absorbed. The process is repeated 2 or 3 times until all carbon dioxide gas is absorbed. Then close the stopcock of the potassium hydroxide absorption bulb. When we move the water reservoir downwards, the remaining flue gas rushes back into the gas burette. There will be decrease in volume of flue gas due to the absorption of carbon dioxide by potassium hydroxide. This decrease in volume of flue gas is measured by leveling water in gas burette and a reservoir to the same level. Therefore, decrease in volume of flue gas is equal to, it will give the volume of carbon dioxide. The second step of estimation involves estimating of oxygen. In this step, we follow the same procedure as we have already done for carbon dioxide absorption. That is, opening of stopcock of middle bulb, that is B bulb, containing alkaline pyrogallic acid, and sending the flue gas into the bulb by moving the water reservoir upwards. There will be absorption of oxygen in the flue gas by alkaline pyrogallic acid. And sending the flue gas into the bulb by moving the water reservoir upwards, there will be absorption of oxygen in flue gas by alkaline pyrogallic acid. The process is repeated 2 to 3 times until all oxygen is absorbed. The stopcock of middle bulb is closed, that is B bulb. Therefore, here when we move water reservoir downwards, the remaining flue gas comes back to the gas burette. Again there will be decrease in volume of flue gas due to oxygen absorption by pyrogallic acid, which is alkaline in nature. This decrease in volume of flue gas is measured by leveling water in gas burette and water reservoir to the same level. Therefore, decrease in volume of flue gas gives the volume of oxygen. Here you can see in the reaction, the reaction says, it explains the reaction between pyrogalal. Pyrogalal is nothing but benzene triol. On reaction with potassium hydroxide, it gives potassium pyrogalate, and it absorbs oxygen resulting in water. In the third step, by following the same procedure, the third bulb is opened and the flue gas is made to enter the third bulb, that is C bulb, where ammonical cuprous chloride solution is taken and it absorbs carbon monoxide and flue gas. The process is repeated 2 to 3 times until all carbon monoxide is absorbed. Stopcock is closed. Decrease in volume of flue gas is measured by following the same procedure. Here, the decrease in volume of flue gas gives the volume of carbon monoxide. At last, but not least, after the absorption of carbon dioxide, oxygen and carbon monoxide in flue gas, the remaining flue gas contains nitrogen. So, the volume of nitrogen can be estimated by deducting the total volume of carbon dioxide, oxygen and carbon monoxide from 100 ml. Here 100 ml is the definite volume of gas mixture that is to be taken while doing the experiment. Finally, let us go to the precautions. Here, while doing the experiment, it is necessary to follow the order of absorbing gases. First carbon dioxide, second oxygen, and then finally carbon monoxide. As carbon monoxide quantity is less, it should be measured carefully. Thank you.